So thank you. My name is Maria Guerra de Navarro. Um, Thank you for staying this late for this talk. Let's start because I do have a few slides. So let's start by the basics. What are PFAS? PFAS are man-made compounds that are comprised by a carbon fluorinated chain. This grants them a stability and makes them very difficult to biodegrade in the environment. Therefore, they have become ubiquitous. And they also, this stability property has made them attractive to be used in many of our daily life applications. The big problem with PFAS is that there are some health impacts that have been related to being exposed to PFAS that include lower fertility, liver cancer, child development impacts, and so. So how are PFAS generated? They're mainly generated in industry where they are produced or used as starting materials, also in places where they use firefighting foams. And this way, the PFAS reach the environment, become part of the atmospheric particulate matter, moves with the wind and deposits through the deposition, wet deposition or dry deposition, and it reaches the surface water and the groundwater. Today, I'm going to present some data from surface water and groundwater here in the Bay. So in Dr. Quinete's group, we have researched the Bay for PFAS several times. One of the first ones was when we looked into the Bay and some of their tributaries. In this opportunity, we identify a specific profile coming from different areas. Mainly, the highest concentrations were detected in the tributaries. And based on the PFAS profile identified in the Bay, we see legacy PFAS, which are known as PFOA and PFOS, which are the banned PFAS, and emerging PFAS that are being used to substitute these legacy PFAS. So later on, we did a research in different transects of the Bay and also in the depth, like a depth profile. We found a dilution from or decline from west to east of the PFAS concentration and a surface enrichment and depth depletion pattern in the Bay. The northern area of the Bay showed the highest concentration, and again, the same profile of PFAS indicating legacy and emerging contamination. Then later, we did a collaboration with the Miccosukee community, and we monitor some specific areas from the Everglades and also water from the tributaries, Biscayne Canal, Little River, and Miami River. The highest point of contamination was identified at Siebel Canal, at least for PFAS contamination at that time. Levels of PFOS were above the FDEP recommended regulation. And again, we found the same group of compounds identified before being the highest concentration. So this is important because Biscayne Aquifer is shallow and is communicated directly with Biscayne Bay. And this communication indicates a continuous pathway for contamination. So the Biscayne Aquifer is monitored for PFAS every 4 months by Miami-Dade, and we requested access to this data from the county. We had access to data for PFAS from 2019 to 2023. These involve monitoring wells, raw waters before any treatment and after treatment, which is what we receive at home as tap water. The Analysis was performed by a certified lab using EPA methodology, and it involved a variety of PFAS. It's important to highlight that the county manages the water distribution based on, in three major areas, Hialeah, Preston, Alexander Orr, and South Dade. Comparing the sum of PFAS in this area, we see that Alexander Orr exhibits the lowest concentration of the sum of PFAS and is significantly different from the other two sub-areas. The more frequently detected compounds confirm what we have been seeing in the surface water. So 6,2-FTS is a compound that is normally linked to firefighting foams. PFPA is related to food packaging, and PFHXA is related to water repellent clothing. And these three are associated with emerging contamination. And it's also important to highlight that in 90% of the samples of this data set, PFOA and PFOS were detected, which entails the legacy contamination that I have been talking about. So we did a heat map with the average sum of PFAS of this data, and we identified some hotspots. We also included some potential point sources of pollution close to these hotspots. The highest concentrations were found in the Hialeah Gardens and Leisure City Wells. There is another way to look at this data based on ratio indicators, which we also did. And we have three indicators that help us identify point sources of pollution, which is these, and these. And in this case, what this tells us is, at least for South Dade sub-area, there is less impact from point sources of pollution. We use this other indicator for rainfall influence, which affects more in the Hialeah Preston wells. And we also have a specific indicator for industry impact, which in this case, when this indicator is between 7 and 15, it is associated to industry impact. In this case, South Dade is the area that is more impacted. And when this indicator is above 15, it is related to degradation process going on. So precursor degradation, which was the case for South Dade area. So what this tells us is that the contamination that is happening in South Dade is not from emerging pollution, but probably from legacy. We also looked at the temporal trends in the different areas. We found a peak during 2022 for 6,2-FTS that, as I mentioned before, is related to firefighting foams. So we found that back in 2022, there was an increase of the amount of passengers that were using Miami International Airport of about 36%. Whenever this happens, there is also an increase associated with fire training or fire drills. So this increase could be associated with the release of firefighting foams. And because we see that there is a depletion as well, we think that the recent awareness of the use of PFAS and the new regulations associated to the drills has helped to prevent the PFAS from reaching the wells. We also see significant differences for the rainy season and the dry season. And of course, during the rainy season, there is a higher sum of PFAS that is entering the aquifer. And in terms of regulation, we had a look into the tap water, the data from the tap water, and we see that there are exceedances regarding the levels of PFOA and PFOS compared to the maximum contaminant levels, as well for, in some cases, being higher the hazard index that is the limit that comes in the regulation. But there are really challenges because we looked into the 6 compounds that are regulated by the National Primary Drinking Water. And in all of the cases, the water after treatment, the one that reaches home, has higher amount of each of these compounds than in the well. So clearly the current treatment is inefficient to remove PFAS. We contacted Miami Water and Sewage Department, and they did say that they are doing pilot scales testing right now with at least 3 different technologies using the ion exchange resins, the granular activated carbon, and high pressure membranes, as well as controlling the input from the higher concentrations or higher level wells into the mix. So that's part of the challenges. And my take-home message for you guys is that definitely PFAS are pervasive in the aquifer. The profile that we identify of the different types of PFAS, it entails that there is a legacy contamination and one that is emerging, that is going on. We identify specific hotspots at the Miami Spring and Leisure City wells. And of course, groundwater is a continuous source of PFAS to Biscayne Bay. Therefore, we think that it should be integrated into the bay restoration strategies. So I acknowledge my funding sources, Dr. Quineta, for the opportunity to collaborate with her in this research, and my lab mates. If you have any question, thank you for your attention.